Hi everyone. In this video tutorial, we will simulate low velocity impact to composite material using Abaqus. We will use Hashin property of composite material to see the failure in our composite material. Also, we will use the impactor as a rigid part. In the result, we will get some data and see the failure and damage of composite and also see the animation. And in final step, we will get the total energy in our model. Let's get started. Let's start with creating our part, our composite plate. Let's start with in the module part. Go to create part and name it composite plate. 3D deformable solid extrusion, and let's add size to 1000. We continue, and now let's create our sketch, our profile of our plate with dimensions equal to 500 millimeter, 500 millimeter. Click done. Now let's add the thicknesses of our plate equal to 2 millimeter. Click OK. Now we have our composite plate. Let's add some partitions by sketching. First, let's create sketch in our top faces of our plate, of our composite plate. Select the vertical line. Now we need to create a rectangular to make partitions in our part. Click done. Now we have sketch. Let's create part using this sketch. Create partition, select cell, use planar sketch planar partition. Let's use inside patch, select edges. The first one. Now extrude sweep edges. Let's select this one. Second, third, and fourth. Click done. And now let's select direction of extrude. Select this direction. Click OK. Create partition. Now we have partitions in our part. The second part in our model is the impactor or projectile. Let's create projectile or ball. 3D deformable. Let's change type to discrete, rigid, solid extrusion. Click continue and create circular profile. Now we have, let's go back. Let's skip. On 3D deformable discrete rigid, solid revolution, type of revolution, continue. Add dimensions of our parts equal to 35 millimeter in the radius. (360 millimeter degrees of rotation or revolution). Now we have our projectile ball created by Abaqus. Now, because we have this ball analyzed as rigid part, the first option you need to do is to create reference point to apply all boundary condition and any boundary condition and load in this point. The second option is to convert this solid part to hollow part by using create shell from solid option, create shell from solid, select this part, click done. Now we convert this the solid ball to hollow part. Now click done. Let's go to property module and import our composite material from library. We have two materials, the second one and the third one. In our model, double click on this material. This double click we have imported in, you can import it in our model. Now let's take a look at our material. Edit. We have density of our material in the ton per millimeter cube unit. The second parameter is the elastic material, elastic property. And the third property is the Hashin failure or Hashin damage property of our composite. And also we have damage evolution property and also damage stabilization parameters. Now let's go to create, assign property material, assign composite material to our part. Go to create composite layout, name it composite. The initial play count we need to use, for example, 6 layers. We need to use continuum shell because we have solid part. We don't have shell element. If we have shell element, you can use conventional shell, but we have continuum shell because we have element, we have solid part. Click continue. Now the first option is select the region, edit region, select the part, select region for the play 1 2 3 4 5 and 6. Click OK. And material, edit material, select this material. OK. Relative thicknesses, edit. You can use thicknesses in our part 0.5 for example, but we have a wrong value. We have the total thicknesses in this part equal to 3 millimeter, and in our model, in our part, in our solid, we have 2 millimeter. Abaqus, when we need to evaluate the thicknesses, use these value. Don't use 2 millimeter, but use 3 millimeter. And now we need to use angular rotation angle, for example 0 45 minus 45 0 or 90 and 0 60 90 60 for example, or let's change it to 30 60 and 90. It's depending to your problem on your angle in your plate. And integration point, you can use 3 or convert to 1, change to 1 for example, edit, you can use 1, click OK. Now we have assigned material property, composite property in our plate. Let's go to query, play stock plot, select, and now can you see here we have 6 layers with thickness equal to 0.25 and all direction in our plate. Now let's edit our property to see the direction or reference direction in our plate. This is the main option in to assign composite to our part. We have layup orientation. In this option we use part global. That means we need to use the directions of our global model to assign rotation and angle to our part. That means we have 0 is in the x direction. Can you see here? Let's take a look. We have the reference point is with the x direction, the first direction, and the second one, the direction 2 is with the y direction, and 3 is with z direction. This take the orientation global of our part. You need to take this in consideration of our orientation to our plate, of, orientation of composite in our part. Click OK. Now let's go to assembly and create two instances. Select two instance, apply. Now let's translate all wall model in the the, the xy direction in the middle in the 0 point. First let's create middle point, the first one, second one, we have this point, and now we need to translate this part to the 0 point. Select this point, 0. Now we have the plate is in the middle of plate is in the 0 position. Click OK. Now the ball is already in the 0 position. Let's translate up to the plate in the z direction. Let's select part, done. Translate the 0 point of our ball to we have the reference point to, for example, 500. Now 0 point 500 millimeter from the top face of our part. Click OK. I think we need to rotate this part. Let's click on it. Select axis of rotation, X. Click OK and translate the reference point to 100 millimeter. And now we have good orientation of our ball to in our model. Now let's go to assembly module and to step module and create dynamic analysis step, dynamic explicit, continue. Click OK, and let's go to edit file output and select the failure of our the value of failure or variable damage, and select also Hashin failure, value, and also let's go to status to see the failure of our layers. Click OK. Now let's go to interaction and create interaction property in the contact between the ball and part. Create two property, tangential behavior, normal behavior, penalty equal to 0.3. Click OK. And now let's create the contact. Surface to surface contact. Continue. Select the first surface. Select the brown side of our part, the outside face, because we have hollow part. We need to select the outside brown. Create surface and select the top surface with in the contact. Click OK. Now let's go to load dynamic in the initial step, symmetry, anti-symmetry, and caster. Continue. Select the outside cell in caster. OK. And now also in the initial step, select the reference point of our ball. Click done and select now. Select displacement rotation. Click continue. Select reference point and select these two directions to avoid the movement and translation in this direction. You can also avoid the rotation. Click OK. This is the only direction of translation is in the Z direction. Now is in the Z direction. Click OK. Now let's go to also in the initial step, in the step 1, mechanical velocity angular, or you can use predefined find as the initial is a, initial velocity, mechanical velocity, continue, select the reference point, continue, and add the velocity in the direction per millimeter per second. Click OK. Let's go to mesh and element size 10 millimeter. Yes. And go to element type. Let's go explicit analysis library element. 3D stress. Let's use continuum shell because we have continuum shell. And click OK. Now let's go to mesh our ball. Element type 10 millimeter. Apply. OK. Yes. We need to change to 5, for example. Shape our ball. Apply. Delete previous mesh. OK. Mesh. Yes. Element type. We have described rigid element. OK. Now to the composite plate. Let's go to assign direction of our stack. We have a good assignment of our direction because we have sample part. Click OK. Now I think you need to go to part or property and add the mass to our ball. Go to ball, engineering features, inertia 1, point mass inertia. Click continue and select reference point to add mass to our ball. The mass is equal to 0.005 or zero 0.01. That means we have 1 kilogram our ball. This value is in the ton unit. That means we have 1 kilogram in the mass of our ball. Click OK. Now let's go to step again, and I think we have all necessary variables. Okay. Now I think all things are done. Let's go to job and create our job. Continue. Okay. Check our model first. Now we have completed job. Let's go to the result and see our variables and result in simulation. First, let's see our deformed shape. Animate. This is our animation of our low impact velocity, low velocity impacts to composite layer. Let's see our data, mices, stress, and also we can see different variables in our material, in our result. Damage in compression, damage in traction, shear damage, and now we can plot some energy of impact. Let's plot total energy of our test. This is time of is in contact between the impact ball and the composite layer, and this is the energy, total energy of our assembly of our impact test. This is the energy total of the whole model, and this is the animation of our test. Until now, I hope you enjoyed this video. Don't forget to subscribe in my YouTube channel and like this video. See you in the next